Okay, I will to introduce the nature science. The fundamental purpose of nature science is to find the law that lie behind nature phenomena. But the work of nature science does not include the study of why this law exists. Nature science holds that supernature, arbitrary, and contradictory phenomena do not exist. The two most important fields of nature science are observation and logical reason. National natural science can lead to law in nature by observation and logical reason. If we observe phenomena different from that predicted, it is the error because there is an error in the observation, or because the law which has been through to be should is wrong. There is no supernatural element. I want to introduce a machine. The machine contains a mixed grid and is sometimes considered the world's first wrong computer. Through a perfect representation of the struggle may be others smile is treatment from recent time that have yet to be discovered. The machine was probably built according to astronomical and mathematical through developed by the ancient Greek at between 150 and 100 BC. Darwin's fish are the group of closely related fish species that live in the Galapagos and Cocos Islands and have evolved a variety of breeds and behaviors due to the different habits. These birds provide strong support for Darwin's rule of evolution and have long been example of repeated evolutions.
Natural science is the study of empirical objects in this universe. Natural science studies various phenomena and events that have benefits for human life. In natural science, the object of research is all objects in nature, while social science will talk about individual human beings and their behavior. The thing that starts in the formation of science is the preparation of a hypothesis for the opening of research. Based on the object of study, science can be called empirical knowledge. Natural science has assumptions about objects, including assuming that certain objects have similarities to each other, namely in terms of structure and properties, assume that an object is unlikely to change in a certain period of time, and assume that each symptom is not an accidental event. In the view of empiricism, science does not require an absolute causal relationship so that a certain event must be followed by another event. The science of empirical object is basically a simplified abstractions. This is necessary because natural events are very complex. Activities carried out in the natural sciences are not objects of natural science research because the practice of natural science is a unique human activity. Humans can indeed be involved as a subject and as an object. The hypothesis itself is a theoretical formulation that will be tested, otherwise known as a tentative answer and in the form of temporary conclusion. In this case, the formulation of hypotheses requires inventive intelligence to find new things that are needed. The pattern of approach in research testing can use in the form of induction. From the natural facts that interact with senses, observations and measurements can be made. The next process then recorded as documented data. This data later separated according to certain criteria is called classification. The next stage, post-classification, is to interpret the relationship and connection between data, which is formed into a conclusion based on the premise, become part of the hypothesis starting with specific things and generalizing to general things. Logic plays an important role from conclusion that are formed. In mathematical schemes, the terms modus ponens, modus tollens, and syllogism are known, using logical derivatives in if and then assumptions. It is not easy, even making data linkages to hypothetical conclusions requires creative imagination. In the end, the analysis of the relationship between data and the description of the relationship can be called a theory after testing. At the final stage, a theory that can be accepted by the public and researchers can be called a law. The transformation of empirical facts into a statement of hypotheses and theories in which there are main principles, namely simplicity, testability, and universal application. In this case, the hypothetical framework can be associative, causal, relational, comparative, or descriptive. In testing a hypothesis, relevant and relative factors are needed. In a different approach, we recognize the deductive method of hypothesis testing, where the process of connectedness starts from the aspects of general things to specific things. The deductive nature is used because not all facts can be obtained, while there are preliminary conclusions or theoretical hypotheses can be formed. Thus, additional auxiliary assumptions are needed. In order to carry out experimental tests on these general matters, natural science recognizes the type of theory that cannot be formulated as test results. These are often referred to postulates. Later, a well-tested and study will see the level of acceptability and credibility of the research results. In this case, the study must have the principle of testability, which is about to ease the testing of hypotheses. Furthermore, a favorable final theory or hypothesis has the character of representing widely and confirmed evidence or facts. It could be that in the future, if new facts are found, it is necessary to test the consistency of the results. The form of proving the hypothesis is through the induction method with fact verification, while in the deduction method the results are falsified, namely the reverse proof of error. However, one thing that must be avoided to attempt to generalize social science using natural science not as pseudo-hypotheses, such as likening the problem of human love to Newton's theory of gravity about the interaction of attraction between objects. One thing is for sure, not all events can be translated by humans through the mind, and philosophy provides a basis of systematic, logical, and rational framework for thinking both as practitioner and academics. With the science of logic, which is also a branch of philosophy, faithful practitioners and academics are equipped with a frame of mind that will be very useful in the thought process. All science is built on the foundation of logic. The method of approach and drawing conclusions from each existing premises are entirely based on the principles of by logic. By studying natural science systematically, scientists, both practitioners and academics, will be able to develop science systematically, logically, and rationally.
So now I will try to explain number C regarding the Torricelli's case and its implications in the development of the natural sciences. So Evangelista Torricelli was an Italian physicist and mathematician. He was known for his invention of the barometer. His contributions to science, including a theory describing the relationship between temperature, air density, and wind, mathematical equations describing the rotations of curves and solids, which led to the development of calculus, and the physical evidence and philosophical arguments proving the existence of a vacuum. So Torricelli's experiments with liquids and gases added to the development of a new scientific worldview, which broke away from Aristotelian and church authority during the 17th century. He was a committed Copernican and advocate of Galileo's theories, who was familiar with the works of Johannes Kepler and other revolutionary thinkers of his age. And his invention of the barometer opened a new era of experimentation in physics and meteorology. Pascal, Lavoisier, and others used the new instrument and Torricelli's theories to verify the reality of air pressure and mechanical reality. In the case of Pascal, the new understanding led to a liberal and progressive view of scientific progress in the discovery of truth. Therefore, the impact of Torricelli's discoveries can be seen in the writings of Blaise Pascal, as well as others who demanded a rational and scientific approach to exploring and understanding the world of natural phenomena. Torricelli's presentation of the mathematics of solids and curves rotated in space represents a segue from classical geometry and solid geometry to a newly emerging mathematics leading to modern calculus. So I think that is all for my opinion for number C. Thank you so much.
Let's just moving on to the next questions. So the next question is, what are the stages of natural science that ensure scientific knowledge of nature and also the example of it? Before we're moving on to the stages of natural science, we need to know what natural science exactly are. The natural science, or a philosophy of nature, was the philosophical study of nature and a physical universe that was dominant before the development of modern science. This study was considered as the ancestor of the natural science. Um, well, there was not very much different between the science and also the philosophy, because in this case, science is about the empirical knowledge, while the philosophy is also about the primary knowledge, if it exists, and the other one was that science is about continuing facts, and while the philosophy is also about the necessary truth, which it happened when this world exists. Science is also about descriptive, and philosophy is all about normative truth, if it exists. Now let's moving on to the first stages of natural science. So the first one is we need to identify the main problem or the anomalies. And then after we already identify the problems and we know what the problem is, we're moving on to the next step, which is we need to formulate the hypothesis. Well, in this case, we can take an example in a Torricelli case. In his case, he need to formulate the hypothesis between the air pressure or the Facui horror hypothesis, or the Facui horror hypothesis, or the empty space. And after formulate the hypothesis and already got the answer, when it's moving on to the next step, which is the justification of the hypothesis as a scientific law through a falsification process. Falsification process is a way of demarcating science from a non-science, and it suggests that for a theory to be considered scientific, it must be able to be tested and conceivably proven false. For example, the hypothesis that all swans are white can be falsified by observing a black swan. In this case, we can take an example again from the Torricelli case. The justification of the case regarding air pressure with a barometer. That was the example of these steps. And the last one is abstracting natural laws so that they become scientific. So that was basically the four steps to ensure the natural science as a scientific knowledge of nature.
Okay, so next is about the truth in natural science and the difference with the truth in math. So I've been explained about the truth in math in the first video before, that the truth in math is considered as a coherent truth, which means it's a truth that follows logic. Every mathematics science should adopt at least one system in the entire time of their learning in mathematics, because it will see mathematics in objective ways. The difference with natural science is natural science, the terms of truth isn't used because it's a philosophical or metaphysical sense, and it's a correspondential truth, or it was related to the world and there's no final truth. And the last is about the critical reflection of the creator based on the phenomena natural order. So science were built and structured not from verification process but from falsification, which means in philosophy of science, a theory experiences falsification if it is contradicted by an observation or experiment that is logically works. So none of these science objects are free from subjective constructions, and since scientific experiments guided with paradigms which explicitly contain in the normal science process, nature will always follow its objective laws. It is a sign that nature was designed to follow the creature, and in short, the world of physics always consists with numbers and is structured with mathematics, which always follows logic, while the world of sense or natural science is constructed by abstraction, where human sense always implies.